Okay, this is the first time of many that you're going to see a picture like this because they re-trot this one out all the time. But it's going to be something on a ramp, right? Something on an incline. Or it could be a hill, whatever, but it's all the time the same thing. And you kind of have to understand a little bit of like balance of forces. If you've taken physics at all, maybe you've done a little bit of things like this. It says a force of 600 pounds is required to pull a boat and a trailer up a ramp that's inclined at 15 degrees from the horizontal. Find the weight of the boat and the trailer. Well, which direction is the force being applied, which is pulling this thing up the ramp? Along the ramp, right? I mean, let's say it's along a ramp and there's a truck that's pulling it in front of it, right? Somehow. So that 600 pounds is being pulled in that direction. Now, we want to find the weight of the boat and the trailer. What's the force that's acting there? It's gravity, right? In what direction is gravity pulling? Straight down, right? Gravity is this vector, which is going straight down. So that's this right here. Now, we want to find that. The only number that we've got is this 600 pounds, which is being applied to keep the boat from going backwards. We can assume that we got a balance of forces here. So what we need to do is to take this gravity vector and break it down into components, right? One component has got to be applied exactly opposite of that, right? We know gravity is pulling down like this. And means part of it is pulling against that, part of it is not. But this little vector right there, right, is exactly parallel to this vector. So one's pulling up, the other one's pulling back. And we know that they're balanced because the thing's not moving. Right? It's got to be a balance of forces here. So what is this force right here? 600 pounds. If it was 600 pulling that direction, it must be balanced by 600 in the opposite direction. Now, you can use similar triangles to show that if this angle here is 15 degrees, then this angle in the triangle is also got to be 15 degrees. So this is what we're looking at with this triangle there, if I make it bigger, right? Gravity is pulling straight down. There is a component of that which is exactly opposite of that. That's 600. That's 15 degrees. And we want to know the weight of the trailer. And weight is a force, right? Weight is a force. It's your mass with gravity pulling down. And that would be that. So notice that this, there's gravity, it goes straight down. This component is exactly parallel to that. This one is going perpendicular to the ramp, which makes this a 90-degree angle. So this is right triangle trigonometry. So how are we going to find x? The sine of, no, you don't take the sine of the 90-degree angle. The sine of which angle? You only know one, right? So it's got to be sine opposite over hypotenuse. The sine of 15 equals 600 divided by x. Solve for x. X equals 600 divided by the sine of 15. Which is 2,318 pounds. So in these problems, sometimes they tell you the weight of the ramp, right? The weight of the thing that's on the ramp. And they ask you to find that. Sometimes they tell you this, and they ask you to find that. It's got to be one or the other. But it's always the same picture. It's always set up the same way.